All right, section 4.8, we're talking about complex numbers. And so the first thing we're going to run across is the idea of the imaginary unit. In this case, we're talking about the letter I. I is the complex number whose square is -1. So I squared equals -1, and I itself equals the square root of -1. And ideally, what this is going to allow us to do, it's going to allow us to find the square root of negative numbers. Because we're then able to, and let's look at this example here at the bottom. If we have the square root of -a, we can then break this apart into the square root of -1 and the square root of a. Taking out the square root of -1, we're left behind with the square root of -a, or square root of a. And we know the square root of -1 just becomes I. So we have I square root of a. And then if need be, we could reduce the square root of a more if necessary. If it's a perfect square, we can find the square root that way, and so on. So here it says, how do we write the square root of -18 by using the imaginary unit I? So the first thing we're going to do is we're going to take the square root of -18, and we're going to recognize that this can be broken down into the square root of -1 times the square root of 18. All right, the square root of -1 we know is just I. But here's the thing, the square root of 18 is not a perfect square, but it can be broken down farther. So we get the square root of 9 and the square root of 2. We can square root 9, which is great. That's what we want to do. The square root of 9 is 3. So we've got I times 3. The square root of 2 can't be reduced anymore, so that's the square root of 2. And so our final answer just becomes 3I square root of 2. We're going to simplify our radicals. Here we have a few more examples. So same idea here in the bottom one, question 12, or A. We would break this apart into the square root of -1 and the square root of 12. The square root of 12 can be broken apart into the square root of 4 and the square root of 3, since it's not a perfect square. This becomes I. The square root of 4 is just 2, so we've got 2 times I times the square root of 3. And so our final answer just becomes 2I square root of 3. For the next example, we've got the square root of -25. Well, that one's pretty easy. It becomes the square root of -1, square root of 25. 25 is a perfect square, which is 5. And we know that -1 becomes I, so we've got 5I as our answer. And then here, this just becomes square root of 7 times I, or I square root of 7. All right. So an imaginary number is any number of the form a plus bi, where a and b are real numbers and b is not equal to 0. Imaginary numbers and real numbers together make up the set of complex numbers. So what we're going to talk about next is adding and subtracting complex numbers. And so here we've got 4 minus 3i plus -4 plus 3i. So kind of like combining like terms, we're going to do the same thing here. We've got 4 and the -4 to go together, so 4 minus 4. And then we'll take the I values together, so we've got -3 and plus 3i, -3i plus 3i. In this case, we should notice right away that these are going to cancel. This becomes 0. This becomes 0, so our answer is just 0. Question B, same idea. But first, we're going to go ahead and distribute this throughout this quantity. So we've got 5 minus 3i plus 2 minus 4i. So the idea is essentially let's combine some like terms. We've got 5 and 2 are going to become 7. And then we've got -3i and -4i become -7i. And this is our answer. We're treating the I kind of like a variable x in this case, as we would normally for right now. So with that in mind, go ahead and give A, B, C, and D a shot here, and then when you're ready, unpause the video and check your answers. So in this case, if you've done it correctly, for A, you get 4 minus I. For B, you get -2 plus 7i. For C, you get 12i, and for D, you get 18i. Moving on from here, we're going to talk about multiplying complex numbers. And so one of the things you want to keep in mind in this case, as you go to distribute, you're treating this like you would anything else essentially. But when you get an I squared value, in this case, remember I squared in this case equals -1. So anytime we see the I squared, we can transform that into -1 and then continue simplifying our problem. All right, so that's the big idea here. All right, so for question A, we're going to distribute this throughout. So we've got -15i plus 6i squared. And remember what I just said. Because of the I squared on the 6, this is actually -15i plus 6 times -1, which we then simplify to get -15i minus 6. You can also write this as -6 minus 15i. Either one works. Next one down for question B. Essentially, we're looking to FOIL this out. So for FOIL, we've got first, so this is -4. We've got outer, so this is -8i. Inner, that would be -3i. And then last, this would be -6i squared. We know that the I squared is going to become -1, so this essentially becomes +6. So we've got -4 minus 8i. Well, in this case, let's go ahead and combine like terms here. 8i and -3i become -11i. And then we've got +6 because we multiplied by the -1. So the -4 and +6 are going to give us a final answer of this, in this case of 2 minus 11i. All right, same idea for question C. We're going to FOIL. So this is 36. FOIL, that's -6i, -6i. And then in this case, we get minus I squared. So here we've got 36 minus 12i minus a -1 like this. So that becomes a +1. So this becomes 37 minus 12i. Oh, actually, incorrect. Go back. I made a mistake. -6 times -i, this is a +6. So in this case, this is not right here. This actually becomes 0. Sorry about that. This is just 0. So in reality, the 12i is gone. And so in reality, our final answer is just 37. All right, so go ahead and give 4A, B, and C a shot. When you're ready, unpause the video and check your answers accordingly. So for 4A, if you did it right, you get -21. For 4B, you get 23 minus 2i. And then for 4C, you get 41. So here, we're going to be looking at the idea of complex conjugates. And so what we use conjugates for in this case is to help cancel out the I, and in this case, the denominator, because we're looking to divide complex numbers. And in order to do that, we multiply through the entire expression by the conjugate of the denominator. All right, so this is just easier if you kind of take a look at what we're doing. So let's look at A. We've got 9 plus 12i over 3i. The conjugate in this case, kind of think of it as the opposite in this case, means we're going to multiply the top by -3i and the bottom by -3i. Well, when we do this, remember with fractions, you would multiply across, and so I'll write it underneath, so that'd be -27i plus 36i squared, or -30, or not plus, it'd be subtraction here, sorry. Subtraction of -30, or minus 36i over, this would be -9i squared. Well, keep in mind the I squared in this case. This is really going to look more like this. We're going to have -27i minus 36 times -1 over -9 times -1. So here, we know that the minus 36 and the negative 1 are going to make this addition, so we're going to get negative 27i, still stays where it is. This becomes plus 36, and then on the bottom, this becomes a positive 9. And ideally, we can still simplify all of this. 36 is divisible by 9, and I'm going to go ahead and reorder this. 36 divided by 9 is 4. 27 divided by 9 in this case is just 3, so this becomes 4 minus 3i. Okay, in question B, we're still doing the same thing. We want to find a way to cancel out this bottom denominator, and to do that, we multiply through by the conjugate. The conjugate for this particular problem is going to be 1 plus 4i. And so we multiply the top and bottom by 1 plus 4i, and then so that means we're going to have to FOIL out some things and see how things cancel. So on the top, we're FOILing it out. We should get 2 plus 8i plus 3i plus 12i squared. All of that over top of 1 plus 4i minus 4i minus 16i squared. All right, so then we just want to clean up the top and the bottom to see what we're left with. So we've got 2 plus 11i, and then we know that this becomes negative 1, so this becomes minus 12. Still got some work to clean up there, but for right now, this is okay. On the bottom, we've got 1. The i's here cancel, and then this becomes 16 times negative 1, so that becomes plus 16. So we can kind of clean this up one more time. We've got negative 10 plus 11i over 17 in this case. And so this is one way of writing it, but we could also write it this way. Negative 10 over 17 plus 11 over 17i. Both of these work. So we're just simplifying it down, and we'll look at a couple more examples of this. This is a tricky topic. And so if you go back to the top here, the conjugate, the idea is when you have a complex number of the form a plus bi, the conjugate of that becomes a minus bi. So that way when you multiply them out, you're seeing that you get I squared that'll cancel out there. Your middle terms will cancel out. It's a long, so the idea is to cancel out the middle and then get your I squareds to become negative 1, so things cancel out and they condense a little bit better. All right, so let's take a look at, we'll do, let's just look at A and C. Now we can look at A and B and you can try C on your own. So for A, we're going to multiply by the conjugate here, so that'd be 3 minus 4i and 3 minus 4i on the bottom. So we're going to FOIL the top. So when we FOIL this out, we've got 15 minus 20i minus 6i plus 8i squared over 9 minus 12i plus 12i minus 16i squared. So let's just clean this up the best we can. Here we know we can combine these. So on the bottom, we've got 15 minus 26i. And then here, we know this becomes negative 1, so this is actually going to be minus 8 over top of, in this case, the bottom. We know that this should cancel. This becomes negative 1. So on the bottom, we've got 9 plus 16. We can still kind of clean this up. 15 and 8, that's going to be, well, 15 minus 8, 7 minus 26i. And then on the bottom, we've got 25. And so we can just write this 7 over 25 minus 26 over 25i. For question B, we've got 4 minus I over 6i. So your conjugate in this case is just multiplying the top and bottom by negative 6i. And then we just multiply it out. So here, we'll change colors. We've got negative 24i minus, or plus 6i squared over negative 36i squared. So on the top, we know this becomes negative 1. So we've got negative 24i minus 6. In this case, this becomes negative 1, so this is just 36. And so we can kind of start to separate this out. So we'll get negative 6 over 36 minus 24 over 36i. We can reduce this. this becomes negative 1/6 minus 2/3 I, and this is our answer. Go ahead and pause the video and give question C a shot and see what you come up with. It is a trickier one, but you should be okay. Just try to keep track of everything you have, and unpause the video when you're ready. All right, so we talked about this a while back. When we're solving the the quadratic formula, sometimes you will have a negative under your square root, and then we would say no solution, that being in like Algebra 1 and geometry. But now that we have the idea of imaginary solutions and complex numbers, we have the ability to solve those, or at least give a complex solution for this. And so we're going to look at using the quadratic formula to solve this particular problem. And if you've forgotten the quadratic formula, it's x equals negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. And so with this, we're looking at taking our a value, our b value, and our c value and plugging it in and seeing what happens. So that means we've got x equals 3 plus or minus the square root of 3 squared minus 4 times 2 times 5, all of this over 2 times 2. And then we know we simplify it down. So we start simplifying down. We've got 3 plus or minus the square root of 9 minus 40 over 4. This is going to give us 3 plus or minus the square root of negative 31 over 4. Well, in this case, negative 31 is not a perfect square, but we do know we can continue this problem. Normally we would stop here and say no solution, but we can find a solution. We're going to, in this case, break it down a little bit more. And ideally, we don't have to break much down, because what we're going to do is we should recognize now that we have 3 plus or minus, and for this, we're going to pull the negative out in the form of I, and we've got the square root of 31. 31 can't be reduced, so that's as far as it goes. So this is what our answer looks like currently, but we can rewrite this to look more like this. Oops, back up, let me put that in front. Square root of 31 over 4i. So we can finish this problem. We have to then recognize when we get the square root of a negative, we're going to pull out the imaginary number I, and then we continue the process. Sometimes we will have to simplify, sometimes we may not. All right, so let's look at another example. Let's try A together, and then I'll let you do B on your own. So quadratic formula again, this will be 1 plus or minus the square root of 1 squared minus 4 times 3 times 2, all of this over 2 times 3. So simplifying it down, 1 plus or minus the square root of 1 minus 24. And so we've got that over 6. So we've got 1 plus or minus the square root of negative 23 over 6. Well, this means we have to pull out the I, so 1 plus or minus I square root of 23. 23 is prime, so it's not going to be reduced, over 6. So our answer here is 1 over 6 plus or minus square root of 23 over 6i. And let's just go ahead and do B together. It's quick. So here, x equals 4 plus or minus the square root of negative 4 squared minus 4 times 1 times 5. All of this over 2 times 1. All right, so let's simplify it. 4 plus or minus, this is 16. That would be minus 20 all over 2. Well, 16 minus 20 is negative 4 over 2. This time, we can take and have the 4 plus or minus I square root of 4, but keep in mind, now that we have it like this, square root of 4 is a perfect square, so we're going to be able to simplify this even farther. And so what we're going to end up with is 4 plus or minus 2i over 2. Notice that both of your values are divisible by 2, so we can simplify here. So this should end up being 2 plus or minus I. These two become 1, this becomes 2, so we're good.